Number 2 and 3 are balancing redox using the UHI method. And we're only going to do number 3. Number 2 is the same idea. The one tip I'll give you to get number 2 going is, remember, you can always ignore the H pluses and the waters. You don't need those to get started. They're going to reappear later. So just strike them out, and then hopefully the rest of it should become a little bit more apparent. But we'll look at number 3 because it's essentially the same steps. The only difference is number 3 is in basic solution. So the last step we do here, you will not need to do in part 2. Alright, so remember the first step is to draw down the half reactions. Again, I've ignored the OHs and the waters because they're going to reappear later anyway, and it simplifies things to get rid of them. From here, we're going to UHI both half reactions. And before I start, I'm going to make sure that in the red reaction I haven't missed any charges. Looks to me like NO2 is -1 and there's no charge on NH3. Double checking that prevents a lot of problems when you're doing the electrons later. Okay, let's do UHI. First O stands for other, and an other in this case is nitrogen. There's one of each, so we're done. The second O stands for oxygen. Definitely need oxygens on the right side. So I'm going to put not oxygen, I'm going to put water. Remember, we always balance oxygen with water. Next step is to do the H's, and on the right there's lots of H's and on the left there's none, so we're definitely going to need H's over here. Looks like we're going to need 3 here and 4 there, that's 7 H's. But remember, it's not just H, it's H+. Then lastly we have to do electrons. And you'll notice that on the right side over here, everything's neutral. On the left, there are 7 positives and 1 negative. That's 6 positive total. So I'm going to write electrons over on this side, and I'm going to do 6 electrons, because the 6 negatives will balance the 6 positives and make it 0. Remember that our goal is not to make them 0, the goal is to make them the same, and the right side just happened to be 0 in this case. Alright, then we're ready to do electrons. Oh, no, we did electrons. So we've done. We've UHI'd the red one. Let's UHI the green one. We're going to start with O, which is other, and that's aluminum, but there's equal numbers on both sides. We're going to go to the second O, which is oxygen. Clearly this one needs more. Remember, we don't balance with oxygen, we use water. And then we're down to the H's. Clearly this side needs H's, and it looks to me like it needs 4 H pluses, because there were 4 H's on the other side. And then lastly, electrons. The left side is neutral. The right side has a -1 and 4 positives. That's 3 positive totals. So I'm going to write 3 negative electrons on this side. And you do your check. You notice the 3 electrons are on the right here, and the 6 electrons are on the left. That has to be because the green reaction is giving away the 3 electrons and the red reaction is accepting them. Now we know that one reaction, the green one, can't give away a different number than the red one's accepting because they're exchanging with each other. So I'm going to have to multiply everything in the green one times 2. Now I'm going to do some recombining here, and then we'll get back to you. Okay, so here it's written down. You know, if I make mistakes, it's just not multiplying correctly. I'm double checking there's 4 waters, 2 of these aluminums, 2 of those aluminum oxides, 8 of those, and 6 of those. So it looks good. Now we can neaten up. Get rid of the 6 electrons because they're on both sides. You'll notice that we have 8 H pluses on the right and 7 on the left. So that leaves us 1 H plus on this side. And then, are there any waters to neaten up? There should be. I forgot some. Hang on. Alright, so you notice that I forgot to draw the red stuff over here on this side. So there were 2 waters and 4 waters on the other side. So I can get rid of these and get rid of those, and I'm going to have 2 waters left over. So we've neatened everything up. Now, this would be the answer if we were doing it in acid. But you remember, if we're doing it in base, we've got to do one more step, which is we can't have H pluses. So I'm going to add OHs to both sides. How much? Well, it depends on how much H plus there is. There's only 1, so I'm going to add 1 OH minus to each side. Now, once we do that, you remember that on the right side, these 2 will combine together to make 1 water. On the left side, that OH is not going to change at all. It just is what it is. As a matter of fact, when I rewrite it, I'm not going to put the 1 because it makes it look like a 10. So I'm going to rewrite the final answer. Okay, so I've rewritten it, and I think we should be done. Oops, I noticed one more step. We've got a water on the right and water on the left, so that's going to leave just one water on the left. And I'm also going to double check and make sure everything's balanced. There's one N, two ALs, two ALs. 1 O plus 1 O is 2 O's, and 4 O's on that side. Nope, I'm sorry, 1 O, 2 O's, and 1 O is 4, and sure enough there are 4 on this side as well. So always double check and make sure everything's balanced at the end. Now we're ready to put in our numbers. So you'll notice that there was an OH on the left, so that would be this one. I'm going to put in a number. This one, there was nothing on the right. Water, there was one on the left, nothing on the right. And then all the others you can fill in. Looks like there's one NO2, one AL, no, 2 ALs, and 2 ALO2s, and one NH3. So that's the answer.